fact do you know from the lesson today that has to be true about every direct variation? No, Tristan. Well, she can move here. She can move there. 3, 3. How can you make a direct variation out of just 3, 3? I need more information, Nathan. You're right, but I need more information. Does anybody know anything else about this problem just from what we talked about today that you remember it from Algebra 1? Okay, what are you going to use as your original point? You only have one point. Perfect. Perfectly said. So, if you know you have 2 points and you want to find the slope graphically, what Nikki said is perfectly fine. Rise 3, run 3, 3 over 3 is 1. What do you think your y-intercept is? 0. When you fill those in, Nathan was right 5 minutes ago when he said y equals x. Because had it just been a regular slope-intercept equation, there wasn't enough information. But what is the key from them saying direct variation? What's the key of that? Right, has to pass through 0, 0. Perfect. If x and y vary directly, and I've given you just that little piece of information in example 2, and the equation will relate x and y. If x is 3, I want to know y, given that my initial x was 2 and my initial y was 6. If x and y vary directly, and the equation will relate x and y. If x is originally 3, and we want to, if we want to know what y is when x is 3, we have to go back to the original. X was 2 and y was 6 was given in the problem. For a moment, we're ignoring this because what do we have to do with this part first? We need 2 things, don't we, Nikki? The slope and the y-intercept. Is there any other information that can help us with the point 2, 6? Do we know anything else? What is this? Varies directly. What does that tell you? U 0, 0. Good, Sammy. I heard it's from someone else, but I don't know who it was. So, I now know my y-intercept is 0. I know my slope can either be found like this, or as Nikki did earlier when she counted it, she would have done a rise of 6 and a run of 2, and change in y over change in x would have been 6 over 2, which reduces to 3. Once you know m and b, you have your equation. That is strategy 1. However, strategy 2, most students like much better. You take the original and you say 2 is to 6, as 3 is to x or question mark, cross multiply, and my final answer is x equals 9. I still have another bit of work to do here to get the answer. Do you know why? I have to take the given, x equals 3, plug it into the equation, and my new y is also 9 in strategy 1. But do you see that in strategy 2, you go straight to the final answer? And I should have called this guy y right here. That guy should be y. Fix that so it'll look right when you look at your notes later. 2 is to 6, as 3 is to y. Cross multiply, 2y equals 18, divide by 2, and your new y equals 9. What did we know just because of the phrase varies directly? What extra thing did we throw in there, Caleb, just because it said varies directly? Perfect. That was your extra piece of information. Now, there is a vocabulary word we haven't talked about yet. It's not difficult, but in example 3, this is what we're going to hit home. 2y minus 3 equals 5x. Can you put that in slope-intercept form and tell me whether it's a direct variation? It is not. So, that was not what I wanted to use. Let's imagine that we did an example 4. Go ahead, Tristan, what's your question?
Whenever you're, no matter what kind of point slope, it's standard, it's slope intercept or whatever, if there is a number, I know this word, if there's a constant in there, can you just automatically know that it's not direct variation?
As long as it's not going to subtract away. Like if it's there and then there's a zero pair that would get rid of it, then that would help you. But otherwise, if there's a constant and there's not a zero pair on the other side, you don't have a direct variation. Y equals 5 halves x. Do you agree that y equals mx plus b could be used to describe that equation? This is the direct variation equation, and they always call k the constant of variation. Can you please tell me what k is always equal to that you've been doing for all your life? I heard it. What was it? Say it louder. Yeah. Isn't the constant of variation here just equal to m? Is there any difference between the two? No. So if you have a question in the homework that says, please find the constant of variation, what are you going to do? Find m.
Why do you use k constant variation?
I didn't make it up, sweetie. It could have been the, no, it could have been the letter was in Greek or Roman or whatever. Latin, I meant, yes. Thank you, because I knew that sounded stupid when it came out.